Okay, I am on page 33 in my pink math journal, and we are reviewing the math addition properties. The objective, let's just read it one more time. Everyone should put their finger on it. I understand and can show my work using the commutative, associative, identity, and distributive properties. That's enough. Okay, and my learning takeaway. Here are the important things that need to be written down. Everyone should be writing. Add-ins can be added in any order. Get out, start writing. Okay, add-ins can be grouped in any way. It doesn't change the sum. Okay, that's different than subtraction. If I say 7 minus 3 is not the same as 3 minus 7, right? Okay, if I group 4 minus 2, that's different than if I group 6 minus 2. Okay, so this is not true for subtraction. It's only true for addition. Okay, there's another point. Adding 0 to an addend does not change the addend. And then the most important point here of all, why do the addition properties matter? Why do we care? Why do we use addition properties? Addie? True, but why is it important, Cordelia?
It's important to know because we're going to have a test on it and you're going to test us about it.
No, that's not why it's important. Remember we talked about why we would group certain numbers together?
Oh. So it's easier to add.
Right, the addition properties make it easier to add. We put numbers together that are easy to add, and that helps us. It's a lot of times if we can get to numbers that add up to 10, that makes adding them easier. If we have more than 2 add-ins especially, okay? Page 33 that we're on. Page 33. Okay, we need to be able to read your writing. Okay. If you cannot sit quietly, you will have to leave the room. Okay, who can give me an example of a commutative property of addition? Give me an example of the commutative property. If we look back here, remember the commutative property, the flip-flop rule says you can switch the order of the add-ins and the sum will be the same. And here are a couple of different examples. Who can give me an example to put here on page 33? Avery.
2 plus 3.
2 plus 3 is equal to what?
5.
Or we could say what? Just reverse the add-ins. 2 plus 3 is equal to 3 plus 2. And correct, they are both equal to 5. Miss Canterbury was showing us yesterday how you could solve it down on the next line. 2 plus 3 is 5, 3 plus 2 is 5. Okay, the associative property, if you'll remember back, it doesn't matter how numbers are grouped in addition, the sum is the same. Okay, so we had these different examples where here we grouped the 4 and 9, and here we grouped the 9 and 6. Here we grouped the 23 and 7 together. Okay? Give me an example of the associative property. Who can give me an example of the associative property where we switch the way the numbers are grouped? I don't see very many hands. Come on, guys, it's just an addition problem with 3 add-ins. Put 2 of them in parentheses. Who can do it for me? Cordelia.
7 plus 3 plus 9.
Which ones do you want in the parentheses?
7 plus 3.
Okay, so 7 plus 3 plus 9 is equal to what?
19.
Well, 7 plus 3 plus 9. I can change which numbers are grouped together. Here I have my 7 and 3 grouped together. Here I have my 3 and 9 grouped together. What do I do when I see parentheses in a math problem? What do the parentheses tell me to do? Ella.
Tell you to add those first.
Add those first. So here we would have 10 plus 9 is equal to 7 plus 12. And isn't that true? 10 plus 9 is 19. 7 plus 12 is 19. Write it down just like I did. Follow the steps and write them. Step 1, step 2, step 3. Show that they're equal on both sides. Your whole life in math, you need to be sure that you have equal values on both sides of your equal sign. Okay, you're behind. You're not with me, and I've added several things. I have things up at the top as well. Okay, let's look at the identity property. Adding 0 to any add-in does not change its value. Okay, and we did large numbers here. Okay, we did 0 plus 17. That was Ricky's example yesterday. Who has an identity example over here for me? Caden.
6 times 6 equals to 18 plus 8.
Okay, so I need something. Remember, identity means we're adding 0. So I need a number plus 0. Your first add-in can be any number you want.
50 plus 0 equals to 0 plus 8.
Well, okay, sorry. That is an example of the commutative property. The identity property just says if you add 0, it doesn't change the value of the first add-in. It doesn't change the identity. So 50 plus 0 equals 50. Okay, it could be any add-in. Yes,
I have a number.
give me a number.
2,640,000.
10 or 2?
What?
Did you say 10 million or 2 million?
2,648,000.
2 million. 648,000. 586 plus 0. Everyone say it together. What does it equal? 2,648,586. It doesn't matter how big the other add-in is. The value of that add-in, it does not change when you add 0. Okay? The other side and the bottom are about multiplication. So we're not going to fill those out because we're not there yet. But I do have a packet here